close your eyes. The quiet science begins. Tonight, we gently drift into why do stars twinkle. Your eyes are bending light right now, making tiny, constant adjustments to the world arriving at them. And they have been doing this since before you took your first breath. There is nothing you need to do right now, no position to hold correctly, no thought to complete before you can rest. Whatever you were carrying today, the small decisions, the accumulated hours, none of that is required here. This moment asks nothing of you. It only offers something very quiet, very simple, and very old. We are going to spend some time with the night sky tonight. Not the dramatic version of it, not the version that overwhelms you with scale. The intimate version. The one you might have glimpsed as a child, lying somewhere outside in the dark, looking up without purpose, without understanding. Just looking and noticing that the lights up there were moving in a way that made no sense. A kind of trembling that felt almost like breathing. That observation was real. It was accurate. And the reason behind it, it is not distant from you at all. It is connected in a way that takes a little time to arrive at, to the air surrounding you right now, to the way your own body moves through the world, to the invisible, ceaseless motion of the atmosphere pressing down around your skin in this very moment. But we don't need to arrive there yet. For now, just notice that you are somewhere warm, that the weight of your body is being held. Your bed, your floor, whatever surface has you. It is doing its work without any help from you. You do not have to hold yourself up. You haven't had to for a while now. Somewhere in the last hour, without your noticing, you gave that task away. The ground took it. The ground always takes it. Breathe in. Let it go slowly. Your chest rises and falls, and the air moves through you, and outside, somewhere above every ceiling and every cloud, there are stars doing what they have always done. And tonight, we are going to remember very quietly why they tremble. Stars, as objects, are remarkably still. That is the first thing worth knowing. When you look at a star and see it flickering, shifting between brightness and dimness, sometimes drifting slightly in color, sometimes almost seeming to pulse, your first instinct might be that something is happening to the star, that it is moving, that it is unstable, that the light itself is unsteady. But the star is not doing any of that. A star, like the ones you see on a clear night, is typically so far away that the light leaving it has been traveling for years, sometimes for decades, sometimes for centuries, before it reaches the outer edge of our atmosphere. That light arrives here as a beam, so thin, so geometrically narrow by the time it reaches us, that it is almost like a single thread stretched across an unimaginable distance. That thread is steady, at the top of our atmosphere. Before it has entered any of our air, starlight arrives completely stable. No flicker, no shimmer. A point of light as calm as a held breath. The trembling happens here. It happens in the layer we live inside. The atmosphere is not a simple transparent window. It is a living medium. It has temperatures that vary by altitude and by location. It has currents that rise and fall. Regions of warmer air pushing upward and regions of cooler air sinking down. It has water vapor moving through it. Different densities layering over each other, like thin sheets of glass stacked at subtle angles. And when light passes through materials of different densities, it bends. Not dramatically, just slightly. This is called refraction, and it is not unusual at all. It is the same process that makes a spoon look broken when you place it in a glass of water. Different materials slow light down by different amounts, and that difference in speed causes the direction of travel to shift just a little. Our atmosphere is filled with these tiny pockets of variation, invisible to us, constantly shifting. And starlight, that single narrow thread crossing years of emptiness, passes through all of them at once. The word refraction is not one most people carry around in daily life, but the experience of it is something everyone has felt. Think of heat rising from pavement on a summer afternoon. The shimmer above the surface, the way distant things seem to waver, to lose their edges, to become briefly unreliable. That shimmer is light bending as it passes through air of rapidly changing temperature. Your eyes receive it, try to make sense of it, and find that the source keeps shifting slightly. The pavement isn't moving. The cars parked along it aren't moving. Only the light is moving, redirected again and again through pockets of warmer and cooler air. The night sky does something quieter, but structurally identical. Starlight arrives at our atmosphere and immediately begins encountering these layers of variation. A current of slightly warmer air near the ground refracts the beam one way. A layer of higher humidity 2 kilometers up bends it another. A thin region of cold air descending from altitude redirects it again. By the time that original thread of light reaches your eye, it has been redirected dozens of times in the last few kilometers of its journey. And that redirection is not constant. The atmosphere keeps moving. The pockets keep shifting. So, the light arriving at your eye changes direction from one fraction of a second to the next. Sometimes it arrives from very slightly to the left of where it arrived a moment ago. Sometimes from very slightly above. Sometimes through a pocket of air that absorbed a small portion of its blue wavelengths, giving it the faintest orange warmth for just a moment. The star is doing none of this. The star is simply shining steadily, patiently, across all that distance. What you see when you see a star twinkle is actually the biography of the air between you and it. There is something about this I have always found quietly clarifying. The atmosphere we breathe, the same air filling your lungs right now, is not simply the stuff of life. It is also the thing that makes distant light visible and familiar. It bends the universe to our scale. It takes something cold and ancient and geometrically perfect and turns it into something that seems almost soft. The scientific term for what you see when you watch a star twinkle is scintillation. It is a gentle word. It does not try to do too much. Scintillation, from a Latin root meaning spark, a small fire. Something alive at a distance. Astronomers who study starlight must account for scintillation constantly. It is one of the central challenges of ground-based astronomy. When you want to measure a star with precision, when you want to know exactly how bright it is, exactly what wavelengths of light it emits, exactly what its surface temperature might be, the atmosphere gets in the way. Not maliciously, simply by being what it is, a dynamic, restless, living medium. This is part of why telescopes placed in space, above the atmosphere entirely, can see things with a clarity that no ground-based instrument can match. In orbit, there is no air to bend the incoming light. A star observed from space holds perfectly still, a perfectly stable point. No scintillation. No biography written in the air. It is more precise, more accurate, and somehow a little less like the stars you have always known. The twinkling that makes stars seem alive to us, that gave ancient cultures the sense that the sky was breathing, that makes children point upward and feel something they do not yet have words for. That quality comes entirely from the imperfect, restless temperature, varying moisture, carrying air that also moves through you. The stars do not wink at us, but our own atmosphere does on their behalf. Lie a little stiller now, if you can. Not stiff, just settled. Notice the air in the room. It is doing the same thing outside, on a different scale, moving in currents too small and too slow to feel, carrying differences in temperature from the warm spots near your body to the slightly cooler corners of the room. If there were a beam of light thin enough, traveling from far enough away, passing through this room, it would tremble a little. Your breath changes the light in ways far too small to see, but the physics does not stop being true simply because the scale is too small to notice. We are inside the same medium that gives stars their shimmer. This is not a poetic addition. It is literally accurate. The atmosphere extends down to the ground, fills your home, fills this room, moves through you with every breath. You are not outside the thing that makes stars twinkle. You are inside it. Part of it. That is worth resting with for a moment. The air touching your skin right now has mass. It has temperature. It has pressure, roughly the weight of a 10-meter column of itself, pressing down on every surface of your body at all times. You never feel it as weight because it presses evenly from every direction. But it is constant, reliable, present, This same air, in the hours ahead, will continue moving. It will shift through the atmosphere above this building, through the layers above the city or the countryside around you, upward into the colder, thinner regions where commercial aircraft fly, and beyond into the highest reaches, where the air becomes so thin that the sky around it begins to look faintly dark, even in daylight. All of that is one continuous medium, one connected thing. And tonight, somewhere above all of it, the stars are shining, steadily, without effort, without awareness of you. But their light is bending on its way down, shaped by the very air that holds you here, and arriving at whatever window faces the sky as something warm and alive and trembling. The atmosphere has layers, and most people have never had reason to think about them as distinct places. We tend to imagine air as simply air, the same substance from ground to sky, thinning gradually until it runs out somewhere above us. But the atmosphere is more structured than that. It is organized in a loose and living way into regions with different temperatures, different compositions, different behaviors. And each of those regions interacts with starlight differently. The layer you live inside is called the troposphere. It extends from the ground to roughly 10 or 12 kilometers above sea level, though it varies with latitude and season. This is where weather happens, where clouds form and dissolve, where temperature drops as you climb, about 6 degrees for every kilometer of altitude, on average. It is the warmest at the bottom, heated by the Earth's surface, and coolest at the top. This temperature gradient creates constant movement. Warm air rises, cool air sinks, and the whole layer circulates in patterns, ranging from the slow curves of large pressure systems to the tight, invisible turbulence that sometimes shakes aircraft unexpectedly. This is the layer responsible for most of the twinkling you see. Above it, the stratosphere begins, a quieter, more stable region where commercial jets sometimes fly near its lower edge, and where temperature actually begins to increase with altitude rather than decrease, because of the ozone layer absorbing ultraviolet radiation from the sun. The stratosphere is calmer, less convective. Starlight passing through it bends, but more smoothly, more predictably. Above that, further layers exist: the mesosphere, the thermosphere, the exosphere, each with its own temperature profile, its own character, its own interaction with light passing through. But by the time starlight reaches the stratosphere, it has already traveled so far that the additional bending those upper layers provide is modest compared to the turbulent troposphere below. It is the last 10 kilometers, the busy, weathered, life-containing, breath-filled troposphere, that writes most of the story. The air you exhale tonight becomes briefly part of that story. Stars that sit high in the sky twinkle less than stars near the horizon. This is not immediately obvious, But once you know the reason, it becomes one of those things that feels quietly inevitable. When you look at a star directly overhead, its light passes through the atmosphere almost vertically, straight down through the column of air above you. The path through the atmosphere is relatively short. It passes through fewer layers, encounters fewer pockets of variation, and arrives at your eye having been redirected only modestly. When you look at a star near the horizon, the geometry is entirely different. That star's light reaches the atmosphere at an oblique angle and has to travel through a much longer cross section of air before reaching you. Not just the depth of the atmosphere, but the breadth of it. Light slanting through hundreds of kilometers of varying density, temperature, and moisture before arriving at your eye. Every variation in that path has a chance to redirect it. Stars near the horizon scintillate intensely. They shift color noticeably. They sometimes seem to pulse. The planet Venus, when low on the horizon, has been reported as a UFO more than once. Because of this, its steady disk of light broken by the atmosphere into something erratic and colorful, behaving in ways that seem impossible for a point of light. Venus is not doing any of that. It is simply low in the sky. The air is doing everything. Astronomers call this effect atmospheric dispersion, when it separates colors, and they must correct for it carefully. When studying objects near the horizon, the atmosphere acts like a weak prism at oblique angles, bending blue light slightly more than red light, smearing what should be a single point into a tiny vertical spread of color. Most of the time, your eye integrates this so quickly you see only white or yellow light. But in moments of seeing clearly, on a still night near the horizon, you might catch the faintest suggestion of color at the edge of a bright star. A brief reddening, a flicker of blue. That is physics making itself briefly visible. There is a quality of night air that changes depending on where you are. And astronomers have developed a precise vocabulary for it. They call it seeing. Not vision, seeing. A technical term for the atmospheric conditions affecting the steadiness of starlight on any given night. Good seeing means the atmosphere above the observatory is calm, with minimal turbulence, and stars appear as tight, stable points of light through the telescope. Poor seeing means the atmosphere is restless, layered with thermal turbulence, cross currents, pockets of rapidly changing density, and stars bloat and shimmer, losing the fine detail that careful observations require. Observatories are built on mountaintops, partly because of this. Others call higher altitude means less atmosphere above you, less troposphere to pass through, less turbulence accumulated in those final kilometers. The great telescopes of Hawaii, of Chile's Atacama Desert, of the Canary Islands, they were placed there not only for clear skies, but for stable air, for good seeing. Some nights at a high-altitude observatory, The seeing is so good that stars barely twinkle at all. They hold still. They look almost artificial, like points pinned to dark fabric, beautiful in a precise, clinical way. Other nights, even at altitude, the seeing is poor. A storm system far away introduces turbulence that propagates upward through the troposphere. Jet stream winds shear across the upper atmosphere, creating turbulence at high altitudes. The stars blur and shimmer, and the night's work is compromised. Astronomers learn to read the sky before they observe. They watch how stars behave before positioning their instruments. The scintillation pattern itself is information. It tells them what the air is doing, what kind of night this will be, where to point, and how long to wait. The stars, without knowing it, are reporting on the atmosphere. This is the part I keep returning to, quietly. The idea that the same phenomenon, the same turbulent, refracting, shifting air that makes stars difficult for scientists to study is the same phenomenon that has made stars feel alive to human beings for as long as we have looked up at them. Every culture that has watched the night sky has responded to the twinkling. It has been interpreted as breath, as communication, as the presence of ancestors, as signs from forces larger than the human. The technical explanation and the felt experience point toward the same thing. Approached from different directions. The sky seems responsive. It seems to react. The stars seem to notice you. They do not notice you, but the air between you and them does. In its own unconscious way, it carries the temperature of the ground you are living on, the moisture of the region you inhabit, the thermal signatures of cities and forests and oceans. The atmosphere is shaped by the life living inside it. And that shaped atmosphere then shapes how the stars appear. There is a loop there that takes a moment to settle. The living world below affects the atmosphere. The atmosphere affects the appearance of the stars. The appearance of the stars has always deeply affected the living world below. All the navigation, the mythology, the calendar systems built on stellar observation, the sense of scale and time and belonging that comes from lying under a clear sky. All of it downstream of this one, atmospheric interaction. Starlight shaped by the air shaped by life, and life shaped by starlight carried through air. It is not a mystical observation. It is just the system seen whole. The steadiest stars in any sky tend to be the ones burning most quietly. Not all stars are equally bright, and not all bright stars twinkle equally. What determines how much a star scintillates is partly atmospheric, the seeing conditions of a particular night, but also partly geometric. Stars that are closer to us have a very slightly larger, apparent disk in the sky, even though they still appear as points to the naked eye. That marginally larger, apparent size gives the atmosphere slightly less ability to redirect the light fully away from your eye in any given instant. Distant stars, effectively infinitely small as seen from Earth, are more susceptible. But there is another quality worth noticing: color. Hot, blue, white stars scintillate with more visible color variation than cooler, yellower stars. This comes back to dispersion. The atmosphere bends different wavelengths of light by slightly different amounts, and a very hot star emits more light across the full visible spectrum, including the blue end, making the color shifts more apparent when turbulence acts on it. Cooler stars, orange and red stars. Others scintillate with less apparent color change. Their light is concentrated toward the red end of the spectrum, and the differential bending of those wavelengths is more uniform. The twinkling still happens, but the color palette is narrower. So, on a clear night, if you watch carefully, the brilliant blue, white star Sirius, low in winter skies, shimmers with visible color: red, green, blue, flickering in rapid succession. It looks almost festive. Whereas Arcturus, a cooler orange giant, twinkles with more uniform warmth. Its shifts subtler, its character steadier. The sky has texture if you let your eyes slow down enough to read it. The air between you and those stars is writing in color without knowing it writes. Planets do not twinkle, and this is one of those facts that sounds like a trick until you understand why, and then it feels obvious in the way that only true things do. A star, even the closest one beyond our sun, is so distant that no telescope, built by human hands, has yet resolved it into a disk. It remains a point. A geometric point with no width, no apparent surface. Just a single direction from which light arrives. When the atmosphere deflects that light even slightly, nudging it a fraction of a degree, your eye loses it entirely for that instant. The point source disappears momentarily, then reappears as the air shifts again. That rapid appearing and disappearing, that flickering of a point, is what twinkling is. A planet is different. Planets are part of our solar system. They are close enough, not close in any human sense, but close in astronomical terms, that they have measurable apparent size in the sky. Not visible to the naked eye as a disk, not in the way the moon is clearly a disk, but optically, geometrically, they subtend a small angle. Light arrives from them not from a single point, but from a tiny spread of directions. When the atmosphere nudges, one part of that spread off course, other parts still arrive. The deflection that would completely redirect a point source only partially redirects the spread. Some of the planet's light is always making it through from one portion of its disk or another. The fluctuations average out. The planet holds steady. This is why Venus, Jupiter, Saturn, Mars, on any clear night, shine with a calm, unwavering quality that makes them immediately distinguishable from stars once you know what to look for. They do not flicker. They simply are there, pressing their steady light through the same turbulent air, that throws starlight around, like a signal through interference. The atmosphere affects them too. It bends their light. It introduces color shifts near the horizon. But the steadiness holds because they are not points. There is a night in most people's lives, usually in childhood, sometimes later, when they lay somewhere outside and looked at the sky long enough for something to shift. Not a revelation. Nothing dramatic. Just a quiet moment when the scale of what they were looking at became briefly real, and something in the chest became very still. The sky stopped being background. It became depth. The stars stopped being decoration and became distance. And in that moment, the person lying there felt both very small and very located, precisely here, on this surface, under this particular arc of night. That feeling has a physical component. It is not only emotional. When the visual system registers genuine depth, when something about the image being processed suggests vast three-dimensional space rather than a flat ceiling, there is a mild parasympathetic response. The muscles around the eyes soften slightly. The jaw often releases. Breathing slows a little and deepens. The body reads spaciousness as safety. The night sky, when you genuinely receive it, is one of the oldest relaxation signals available to the human nervous system. Not because anything about it is inherently calming in a logical sense, but because our ancestors spent hundreds of thousands of years sleeping under it, reading it, navigating by it, organizing their lives around its patterns. The open sky at night is deeply familiar to some part of the nervous system that predates language, predates culture. The twinkling was always there. The shimmer in Sirius, the steadiness of Jupiter, the slow arc of everything overhead, and beneath it all, people lay down and rested. Light has a speed, and that speed, while the fastest anything in the universe travels, is still finite. This is worth sitting with for a moment. When you look at a star, you are not seeing it as it is. You are seeing it as it was, as it existed at the moment its light departed toward you. For the nearest stars beyond our sun, that departure happened years ago. For stars you can barely make out, it may have been decades. For the faint smudges that are actually distant galaxies, it may have been millions of years. The night sky is not a present moment. It is a collection of pasts, each one a different distance away, all arriving at your eye simultaneously and composing themselves into something that feels like now. And all of that light, every photon from every star and every galaxy you might ever see, passes through the same few kilometers of turbulent air just before it reaches you. Everything the universe has sent across vast time and distance submits, at the very last moment, to the atmosphere, to the moving, thermal, moisture-filled air of one small planet's thin outer layer. The universe crosses the years, and then the atmosphere does what it does with those last few kilometers. There is something in that proportion that the mind does not quite know what to do with. Years of travel, kilometers of refraction, and then your eye, open in the dark, receiving all of it. The color of a star, seen through a steady atmosphere on a clear night, tells you something real about what that star is. Temperature determines color in stars the same way it determines color in heated metal. A piece of iron heated gently glows red. Heated more intensely, it shifts toward orange, then yellow, then white, then blue, white. Stars follow the same physics. They are, among other things, extremely hot glowing objects, and their color reflects their surface temperature precisely. Red and orange stars are cooler. Not cool in any everyday sense. Their surfaces still measure in the thousands of degrees, but cooler relative to the stellar spectrum. These stars burn more slowly, more steadily, often living for tens of billions of years before exhausting their fuel. Yellow stars like our sun occupy the middle. Medium temperature, medium lifespan. The sun will burn for roughly 10 billion years total, and is currently about halfway through that. Blue, white stars are the hottest. Their surfaces reach tens of thousands of degrees. They burn intensely, so intensely that they exhaust their fuel in millions of years rather than billions. In cosmic terms, they are brief. Brilliant and brief. So when you see Sirius flickering blue, white near the horizon on a winter night, you are seeing a star significantly hotter than our sun. One that will have a much shorter lifespan. One that, from another solar system, might look the way our sun looks to us. A nearby bright star in an otherwise ordinary sky. All of that information is in the color. The atmosphere scrambles it near the horizon, mixes it into the twinkling. But high in the sky, on a steady night, the color is reliable. A record of temperature. A fact about physics, written in light, traveling for years to arrive. Others call me nature. The light that left a distant star long ago has passed through a great deal before reaching you. It traveled through the stellar corona of its origin, the outermost atmosphere of the star itself, a region of plasma so hot it emits its own radiation. It moved through the space between stars, which is not empty. Interstellar space contains thin clouds of hydrogen and helium, traces of dust, occasional molecular clouds. The light passes through all of it, and some of it is absorbed or scattered. And what remains carries the signature of everything it has encountered. Spectroscopy, the study of which specific wavelengths of light are missing from a star's spectrum, tells astronomers what elements the light passed through. Each element absorbs very specific wavelengths, leaving dark lines in the spectrum like a fingerprint. Hydrogen looks like hydrogen everywhere in the universe. Iron looks like iron. Calcium, sodium, magnesium, each has its own pattern of absorption lines, its own signature. So starlight arrives at our atmosphere already, carrying an encoded history, a record of what it passed through in interstellar space, what the star's outer atmosphere contains, what the star's core is probably made of, and then it enters our atmosphere. And our atmosphere, without knowing any of this, without caring about the history carried in the light, simply refracts it, bends it according to temperature and humidity and turbulence, scrambles the very precise measurements astronomers need, does not destroy the information. It is still there in the light, but moves the light around enough that measuring it precisely requires patience and correction, and often space-based instruments. The atmosphere that holds all life also makes it harder to read the universe, and also makes the stars seem to breathe. Both things are true. They come from the same source. There are places on Earth where the atmosphere becomes unusually cooperative. High deserts, mostly. Places where the air is dry and cold and stable, where the lack of moisture reduces the turbulence that water vapor creates, where the altitude removes much of the densest troposphere from below you. The Atacama Desert in northern Chile is one of the driest places on the planet. Some weather stations there have recorded years without any measurable precipitation. The air above it sits still in a way that air over oceans, or forests, or cities simply does not. On a night in the Atacama, away from any artificial light, the stars do not twinkle the way you might expect. They are steadier, sharper. The Milky Way, which most people alive today have never seen properly because of light pollution, appears there as a physical structure, not a faint smear, but something with texture and depth, dark lanes running through, where dust clouds block the light of stars behind them, bright regions where star density increases toward the galactic center. People who see it for the first time in conditions like those often go quiet, not because it is overwhelming in an agitating way, but because some proportion becomes briefly apparent that daily life does not offer. You are standing on the surface of one planet. You are inside one galaxy. The band of light overhead is the flattened disk of that galaxy seen from within it, the combined light of hundreds of billions of stars. And the dark lanes are not absence, but presence. Vast clouds of molecular gas and dust, the raw material from which future stars will eventually form. The atmosphere, dry and still, lets all of this through with minimal interference. And even there, faintly, the stars near the horizon still tremble. The human eye adapted over a very long period to make sense of moving light. Motion detection is one of the oldest functions of visual systems. Long before the eye could resolve fine detail, before it could distinguish color reliably, it could detect movement, a shift at the periphery, a change in intensity over time. This sensitivity to motion and change is built so deeply into visual processing that it operates largely below conscious awareness, By the time you notice something has moved, your visual system has already processed that movement and flagged it as significant. Twinkling triggers this. Not intensely, not in a way that causes alarm, but the flickering of a star, its slight positional variation from moment to moment, its color shifts. These register in the visual system as motion and change, which registers as alive. This is not a poetic interpretation. It is a functional description. The visual system categorizes things that move and change as potentially animate. Stars twinkle, and some quiet layer of visual processing responds to that, as it would to any living thing in the field of view. This might be one of the oldest reasons human beings have attributed personality to stars. Not only mythology and culture, though those are real, but something more immediate and embodied. The visual system presents twinkling stars as things that behave, things that vary, things with something like presence. And then the mind, looking for pattern and meaning as it always does, builds stories around that presence. The atmosphere creates the twinkle. The visual system reads the twinkle as life. The mind creates the story, all of it downstream of turbulent air. There is something about the persistence of starlight that I find myself returning to without fully understanding why. A photon leaves a star. It travels for years, or decades, or centuries, through the near vacuum of interstellar space, encountering almost nothing. Then it enters the atmosphere of a small planet and is immediately subject to everything: turbulence and temperature and moisture, and the thermal signatures of cities, and the breath of living things. It is bent and redirected multiple times in the span of kilometers. And then it lands on the retina of someone lying in the dark, looking up. That photon's journey ends in a chemical reaction in the photoreceptors of the eye, where its energy triggers a molecular change in a pigment called retinol, which begins a chain of electrical signals that travel to the brain and are interpreted as light, as color, as a star. The star does not know this happened. The photon, having transferred its energy, no longer exists in the form it traveled in. The journey ends in a translation. From light to chemistry, to electricity to experience. And the person looking up feels, for a moment, connected to something old and far away. They are. That is not a feeling imposed on an indifferent universe. The connection is physical. The photon was real. The journey was real. The chemistry is real. The experience arising from it is as real as anything in the nervous system. What we feel when we look at stars is the end of a physical process. Somewhere in the history of astronomy, someone noticed that stars twinkle and planets do not, and used that observation practically. Before telescopes, before any optical instrument, navigators and astronomers distinguished stars from planets, partly by this quality. Stars flickered. Planets held steady. This was reliable enough in good seeing conditions to serve as a practical identification tool. The wanderers, which is what the word planet means in Greek. From planetes, wanderer, moved against the fixed background of stars, and also shone with a different quality of light. The steadiness of planets was noticed. It was recorded. It became part of the working knowledge of people who spent their nights reading the sky. They did not know about atmospheric refraction. They did not have the concept of point sources versus extended disks. They simply observed, over many nights, that certain lights in the sky behaved differently from others. And they used that behavioral difference to organize their understanding. This is how a great deal of science begins, not with theory, but with noticing. With the accumulation of reliable observations over time. With the recognition that a pattern exists before any explanation for the pattern is available. The explanation came much later. The noticing came first. And the noticing was available to anyone who looked up on enough clear nights and paid quiet attention. Atmospheric turbulence has a scale. This is not something most people consider. But it is part of what makes scintillation interesting as a physical phenomenon. The turbulence in the atmosphere is not random in the sense of being structureless. It has a characteristic scale, a range of sizes at which the turbulent eddies and pockets of varying density tend to operate. The physicist Andrei Kolmogorov, working in the middle of the 20th century, described how turbulent energy in a fluid cascades from large scales to small scales. Large eddies, the kind that make weather systems, break down into progressively smaller eddies, transferring their energy downward through the size spectrum until they reach scales small enough that viscosity, the internal friction of the fluid, dissipates the energy as heat. The atmosphere follows this cascade. Large weather systems break down into smaller circulations, which break down into smaller still, down to the scale of centimeters, where the energy finally disperses. The pockets that most affect starlight are roughly the size of the aperture of a human eye, a few millimeters to a centimeter across. This is not a coincidence that astronomy caused. It is simply the scale at which the cascade reaches that level of the atmosphere, and the eye evolved to the size it evolved, to for other reasons entirely. But the result is that human vision is exquisitely sensitive to this particular scale of atmospheric variation. Larger telescopes average over many of these pockets simultaneously, which is why large telescope images are not simply brighter versions of what the eye sees. They are also different in character, smoother in some ways, and in other ways more affected by seeing in ways the eye does not experience the same way. The eye and the atmosphere are, by coincidence, scaled to interact with each other in a particular way. And the result is the twinkling you have always known. When the atmosphere is very still, on certain nights in certain places, something else becomes visible in the starlight. Not color variation, not positional flickering. Something slower. A breathing quality, a gradual brightening and dimming that happens over seconds rather than fractions of a second. This slower variation comes from larger scale atmospheric structures, broad regions of slightly different density moving across the line of sight like slow waves rather than rapid turbulence. The star seems to inhale and exhale. Sailors noticed this. People who spent long nights at sea with open horizons and dark skies, and time to observe without interruption, developed an intuitive reading of the sky's behavior that was practical and precise. A star that breathed slowly suggested stable air, calm conditions, settled weather. A star that flickered rapidly and changed color near the horizon suggested turbulence, instability, the possibility of weather coming. They were reading atmospheric dynamics through starlight without knowing that is what they were doing. The sky was an instrument. The stars were the signal passing through it. The experienced observer was the interpreter. This kind of knowledge, accumulated through long attention, organized into practical understanding, passed between people who spent their lives outdoors, is sometimes called traditional ecological knowledge, and it is only recently that atmospheric science has confirmed how accurate much of it was. Not mystical, not approximate, genuinely reliable, built from the same physical reality that modern meteorology describes, just approached from the outside rather than from theory. Someone lying on the deck of a ship 1,000 years ago, watching a star breathe slowly overhead and feeling the air settle around them, and deciding the weather would hold, was doing something recognizably scientific. Observing, inferring, deciding the star was doing nothing. The air was doing everything. And the person was reading it correctly. Your body has been doing something this whole time that you may not have noticed, not something you need to adjust. Just something worth a moment of quiet acknowledgement. Your breathing has probably slowed from where it was when you first settled in. Not because anyone told it to. Not because you made a decision. Just because the nervous system, when given enough time in a calm environment with no demands, begins to shift toward its resting state on its own. The breath deepens slightly. The exhale lengthens. The pause at the end of the exhale, that still moment before the next inhale begins, becomes fractionally longer. This is the parasympathetic nervous system doing what it does when safety has been established for long enough. It is not dramatic. It does not announce itself. It simply begins to restore and conserve, to move the body from readiness into rest. The same atmosphere, carrying starlight to your eyes, is moving in and out of your lungs right now, carrying oxygen to your blood, carrying carbon dioxide away. Your blood is currently distributing that oxygen to every cell in your body, including the neurons in your brain processing these words, including the muscles of your chest rising and falling, including your hands, lying wherever they are resting. All of this is happening without your management. The body already knows how to do this. It has known since before you were born. It learned the rhythm of breathing before it learned anything else. You are not directing any of it. You are just here, inside it, benefiting from it. That is enough. That has always been enough. The color temperature of stars maps onto something the human eye understands more intimately than most people realize. The light you find most comfortable, the light that reads as warm and restful rather than alerting, tends toward the orange and red end of the spectrum. Firelight, candlelight, the low sun at the end of the day. These light sources are physically cooler than midday sun, which is whiter and bluer, and the human visual and nervous system responds to them differently. Blue, white light suppresses melatonin production. Orange, red light does not. This is why the recommendation to reduce screen brightness and color temperature before sleep has a physical basis. The body uses light color as a clock. Blue, white light reads as midday. Orange, red light reads as evening, as fire, as the sky after sunset, as the right conditions to begin winding down. The cool, blue, white stars, Sirius, Rigel, Vega, are beautiful in a way that is slightly activating. Their light color is the same range that signals alertness to the nervous system. The warm orange, red stars, Arcturus, Aldebaran, Betelgeuse, carry a color temperature that the body reads more easily as evening, as rest. This is not a reason to prefer one kind of star over another. It is just a quiet note about how deeply the nervous system is calibrated to light and its qualities. How much of what feels calm or alert is written in wavelength? The stars have been calibrating you through the color of their light in ways you have never had to think about. There is a condition called astronomical seeing index, and on the best nights, at the best sites, it reaches a value that astronomers describe simply as exceptional. On those nights, stars through a large telescope hold almost perfectly still. Their light arrives with minimal distortion. The images resolved are sharp in a way that is rarely available from the ground. Details in distant galaxies become visible. The surfaces of planets show structure. Binary stars, two stars orbiting each other, appearing as a single point to the naked eye, resolve into their separate components. Astronomers on those nights work quickly and carefully. They know the window may not last. A shift in the jet stream, a change in temperature at altitude, and the seeing degrades. The stars begin to blur. The exceptional becomes ordinary. So there is a quality of attention that good seeing requires, a readiness to use the stillness while it exists, combined with an acceptance that it will not last. The atmosphere does not hold still for long. Patience and readiness together. This is not unique to astronomy. Most things worth attending to require something similar. The stillness when it comes. The attention while it holds. The equanimity when it passes. The atmosphere teaches this without intending to. Every photon reaching your eye tonight. Others, if you were outside, if the sky were clear, would be completing a journey of such duration that the human mind cannot genuinely contain it. Not because the mind is insufficient, but because the units of experience available to it, days, seasons, lifetimes, are the wrong scale for the measurement. A photon that left a star 80 light years away departed when the people alive then were the living in a world without the technologies that now surround you. Before most of the music you know existed. Before most of the buildings you have ever entered were built. That photon crossed all of that time and arrived here tonight, passed through the atmosphere in a fraction of a second, bent by air that has been here for 4.5 billion years, and landed in an eye that evolved over hundreds of millions of years to receive exactly this kind of information. The timescales do not fit together neatly. They resist comparison, and yet they meet in that moment of reception, in the quiet fact of a person looking up and a photon arriving. There is no word for what that proportion is. There is just the proportion itself, held lightly, without needing to become anything more than what it is. The stars shine, the air moves, the light bends, the eye receives, and somewhere in that chain, something that can wonder about it all lies down and rests. The idea of light traveling for years, only to end its journey in a single human eye carries. Something that does not resolve into a clean thought. It just sits there, quietly, like a stone at the bottom of clear water. You can see it. You cannot quite pick it up. This is not a failure of understanding. It is the natural limit of the scale we inhabit. We are creatures of a particular size, living at a particular speed, built to navigate a world measured in meters and hours and seasons. The universe operates across ranges that are not hostile to us. They simply were not the ranges our cognition evolved to hold directly. We can know them mathematically. We can describe them accurately. But the felt sense of a photon's 80-year journey does not arrive the way the felt sense of an hour's drive arrives. And there is something restful in accepting that. Not everything needs to be fully grasped. Some things can be known accurately and felt only partially, and that partial feeling can still be real and complete in its own way. The stars are far. The light is old. The air is thin and moving. And you are here, receiving all of it, through the instrument of a body that has been shaped over immense time to do exactly this, to take in the world, to process it, to rest when rest is available. Rest is available now. The body knows this. It has been knowing it for a while. The signals are already in the system. The cooled skin, the slowed breath, the muscles releasing their daytime readiness. Nothing left to prepare for. Nothing on the other side of this night that requires you to remain alert for it. Just the quiet. Just the dark behind your eyelids. Just the air moving in and out. Stars are not evenly distributed across the sky. And the patterns we call constellations are not real groupings in space. This is one of those facts that sounds deflating until you follow it far enough. The stars that form the shape of Orion, for example, lie at vastly different distances from Earth. Betelgeuse, the reddish star at Orion's shoulder, is approximately 700 light years away. Rigel, the blue-white star at the opposite corner, is roughly 900 light years away. The stars forming the belt lie at different distances still. They are not near each other in space. They happen to lie in roughly the same direction as seen from our particular location in the galaxy. And from this vantage point, they compose a shape that human visual pattern recognition found meaningful. The constellation is real as a human experience. It is real as a navigational reference, as a calendrical marker, as a story. It is real as a consistent pattern visible from Earth, across human timescales. What it is not is a physical grouping. The stars in it do not know each other. They do not interact. They are simply neighbors in the sky as seen from here. And this is true of every constellation. Every pattern is a projection, not an imposition of false meaning on an indifferent sky, but a genuine meeting between the structure of the sky, as seen from this location, and the pattern, seeking nature of minds like ours. The sky offered raw material. Human attention shaped it into something livable. That shaping is not a distortion. It is one of the things minds do. And the constellations, however constructed, have carried people across oceans and through seasons for longer than writing has existed. The atmosphere that bends starlight is held to the Earth by gravity, which is itself one of the quieter facts in physics. Gravity is by far the weakest of the four fundamental forces. Electromagnetism, the strong nuclear force, the weak nuclear force, all of them are incomparably stronger at the scales where they operate. A small magnet can lift a paperclip against the gravitational pull of the entire Earth. And yet gravity is the force that shapes the large-scale structure of the universe. Because it acts across all distances, accumulates with mass, and never cancels out the way electromagnetic forces can. The atmosphere stays because the Earth is massive enough that its gravitational pull on the gas molecules composing the air exceeds those molecules' thermal energy. The energy of their random motion at the temperatures our atmosphere maintains. The molecules move, they bounce, they rise and fall, but on average, they stay. Mars lost most of its atmosphere because it is smaller, its gravity weaker. and its interior cooled faster, removing the magnetic field that helped protect the atmosphere from being stripped away by solar wind. The result is a planet with an atmosphere so thin that even if you stood on its surface, the sky above you would be nearly black at noon, and stars would be visible in daylight. No twinkling there, or almost none. No thick troposphere to bend the light. Just the near vacuum of space beginning almost immediately above your head. The richness of what we see, the shimmer, the color variation, the breathing quality of starlight depends entirely on having enough atmosphere to do the bending. On living inside a planet massive enough and thermally active enough to hold its air. We live inside the condition that makes stars beautiful in this particular way. There is a phenomenon called a green flash that occurs very rarely at sunset or sunrise over a clear and distant horizon. It lasts less than a second, sometimes only a fraction of a second. A brief intensification of green light at the very top of the sun's disk as it crosses the horizon, caused by the same atmospheric refraction that bends starlight, the differential bending of different wavelengths, separating the colors of the sun's light as it passes through the maximum thickness of atmosphere at the horizon angle. Under the right conditions, a stable atmosphere, a clear ocean horizon, low humidity, the geometry briefly separates the green wavelengths from the red and orange, ones that dominate sunset light, and for just a moment, green is visible. Most people who have seen it describe a particular quality of disbelief, immediately followed by a quiet certainty. It was real. It happened. The atmosphere did something visible and fleeting and precise, and then it was gone, and the sun was below the horizon, and the sky was doing what skies do after sunset. It requires patience to see, and a particular direction of attention toward the horizon, sustained at exactly the right moment, not waiting tensely, just present. Available, the atmosphere offers these things occasionally, brief and unrepeatable alignments of geometry and physics and conditions that produce something unlike the ordinary version of the sky. Most of them go unseen. The horizon is not always watched. The moment passes without a witness. That does not make them less real. Your jaw, if you bring a small amount of attention to it, may have been holding a little tension that you did not know was there. Not a problem, just a habit. The jaw carries the day in a way that is not always released when the day ends. It holds the conversations, the decisions, the moments of effort and concentration as a kind of residual readiness, and it keeps holding, sometimes for hours after there is any reason to. There is no reason now. The muscles around your temples, the hinge of your jaw, the slight pressure of your teeth, these can soften. Not forced, just allowed. The same way the chest softens when the breath has been slow enough for long enough. The body releases when it trusts the quiet. The quiet is here, somewhere above everything between you and the open sky. The atmosphere is doing what it has always done, rising and falling in slow thermal currents, carrying moisture from oceans toward land, bending the light of distant stars as it passes through on its way to eyes that may or may not be open to receive it. The stars are shining right now. Whether or not the sky above you is clear tonight, whether or not clouds have covered the view, the stars are there. Past the weather, past the troposphere, steady and bright and indifferent in the best possible sense, present without demand, available without insistence. Their light is on its way here. It will arrive whether you are awake or asleep. It has always been arriving. The night, as a physical environment, is not the absence of something. It is its own condition, its own set of presences. The temperature drops because the Earth's surface radiates the heat it absorbed during the day back into the atmosphere. And the atmosphere, without incoming solar radiation to balance that loss, cools. This is not darkness causing cold. It is a specific thermodynamic process. The surface releasing energy it borrowed from the sun, returning it upward through the air and eventually into space. The night air that feels different from day air is different, not just darker. Denser, usually, as cooling air contracts slightly, often stiller, because the convective currents, driven by solar heating, quiet down. Carrying different sounds, not because night creates new sounds, but because the same sounds travel differently through denser, cooler air, and because the sounds of the day have mostly stopped. And above it all, the atmosphere becomes fractionally more transparent in some ways. Without the thermal turbulence driven by daytime heating, the seeing often improves after midnight. The air settles into layers more stable than the churning of the afternoon. Stars that were restless at dusk hold a little steadier in the deep hours. Astronomers know this. The best observations often happen in the hours between midnight and dawn, when the daytime turbulence has finished dissipating and the pre-dawn heating has not yet begun. A narrow window of relative stillness. The deep night, in other words, is not simply the day with the light removed. It is a different atmospheric state, a different set of physical conditions, producing a different quality of sky. The stars you see at 3 in the morning are being seen through calmer air than the stars you see at 9 in the evening. The night deepens. The air settles. The seeing improves. The word atmosphere comes from the Greek atmos, meaning vapor, and sphira, meaning sphere. Vapor sphere. It is a simple and accurate description. A sphere of vapor surrounding the planet. Not a perfect sphere. It bulges slightly at the equator due to the Earth's rotation, thickens over warm regions where convection is active, thins at the poles and at altitude, but essentially spherical, essentially a wrapping. That wrapping is remarkably thin relative to the planet it surrounds. If the Earth were the size of a standard classroom globe, the atmosphere, all of it, the troposphere and stratosphere and everything above, would be thinner than a coat of varnish applied to the surface, thinner than a sheet of paper pressed against the globe. Everything that flies, everything that breathes, everything that experiences weather, every cloud and storm and aurora and rainbow and green flash and twinkling star, all of it happens in a layer thinner, proportionally, than the skin of an apple, and that layer is enough. It is exactly enough. Enough to hold liquid water on the surface. Enough to shield the surface from most harmful radiation. Enough to maintain temperatures within the range that allows the chemistry of life to function. Enough to scatter sunlight into the blue sky of day and the red and orange of sunrise and sunset. Enough to bend starlight into something that trembles. The thinness is not a vulnerability. It is a precision. There is a kind of attention that night asks for that day does not. During daylight, the visual system is flooded with information, color, motion, detailed distance, all of it arriving rapidly and demanding processing. The eye moves constantly, making small rapid movements called saccades, repositioning the high resolution center of vision to sample different parts of the scene dozens of times per second. The brain constructs a coherent picture from these samples, smoothing over the gaps, creating the experience of continuous sight from what is actually a rapid series of snapshots. At night, this system quiets. Less information arriving. The pupil dilates to admit more light. The eye shifts from primarily using the color, sensitive cone cells, concentrated at the center of the retina, to the more light, sensitive rod cells, distributed across the periphery. The rods cannot detect color. This is why colors seem to drain from the world in low light. Why moonlit scenes appear in shades of blue and gray. But the rods are sensitive to motion and to faint light in a way the cones are not. So at night, peripheral vision becomes more useful than central vision. Looking slightly to the side of a faint star, rather than directly at it, makes it easier to see, a technique called averted vision, used by amateur astronomers for centuries. The center of your eye goes nearly blind in the dark. The edges see better. This reversal is quiet and strange, and most people never notice it. The eye you use to navigate the day and the eye you use to navigate the night are, in a functional sense, different instruments built into the same structure. Lie wherever you are and let the weight of the day finish leaving. It has been leaving for a while. Not all at once, gradually, the way heat leaves a surface after sunset. Layer by layer. The outer layers went first, sometime in the early evening. The middle layers through the course of the night. What remains now, if anything remains, is the innermost residue. the things that take longest to release, because they are held closest. They do not need to be resolved tonight. Carried things do not have to be set down all at once. The body is already doing what it can, already releasing muscle tension in the sequence it knows, already deepening the breath, already shifting chemistry toward sleep. The mind may still be moving. That is allowed. Thoughts can continue. They do not need to be stopped or managed. They are like stars near the horizon, active, variable, following their own patterns. They will settle on their own if the conditions are right. The conditions are right. The night is here. The air is cool and present. The atmosphere above is doing its ancient work, holding the warmth of the planet, bending the light of distant stars, cycling water from surface to cloud and back. All of it happening without you. All of it completely reliable. You have never had to maintain any of it. Not once. The atmosphere has been here since before anything alive existed to breathe it. It will continue being here. It requires nothing from you tonight. The stars that are most familiar to us, the ones forming the constellations, known in our particular cultural tradition, are all within a few thousand light years of Earth at most. In galactic terms, they are immediate neighbors. The Milky Way galaxy is roughly 100,000 light years across. The stars we see with the naked eye are a tiny local sample, clustered in our small region of one arm of the galaxy. Beyond them, invisible without instruments, the rest of the galaxy continues for distances that make even the farthest naked eye stars seem nearby. And beyond our galaxy, others. The Andromeda galaxy, just barely visible to the naked eye on a very dark night as a faint smudge, is 2.5 million light years away. The light reaching your eye from it tonight left before our species existed, before Homo sapiens walked anywhere, before the ice ages that shaped the landscapes of the northern hemisphere. That light has been traveling since before we were here to wonder about it. And it arrives now, in this moment, and passes through the atmosphere, through the same few kilometers of air holding everything alive on this planet, and reaches an eye that is already closing. The universe sent that light without knowing anyone would be here to receive it. Someone is here. You are here, receiving it even now, even through closed eyelids, even as the mind begins to release its hold on the sequence of thought and lets something quieter take over. The light keeps coming. It always has. You do not have to do anything with it. Just rest. The transition into sleep is not a wall you cross. It is a shoreline. The water comes in. The water goes out. And each time it comes in, it reaches a little further. And each time it goes out, it pulls a little more of the day back with it. You have been on that shoreline for a while now. The thoughts that were distinct and sequential an hour ago have probably already softened. Not gone. The mind does not empty itself on demand, but changed in character. Less linear, more associative. Images arising that are not quite memories and not quite imagination. Small dissolves at the edges of things. The beginning of the loosening that the nervous system does when it has finally decided the watch is over. The watch is over. There is nothing out there tonight that requires your attention. Whatever the world is doing beyond the walls around you, it is doing without needing anything from you in this particular hour. The people you care about are somewhere, resting or moving through their own version of this night. The things that need doing will still be there, unchanged by whether you were awake to think about them or not. Sleep changes nothing about tomorrow, except that you will meet it having rested, having allowed the brain to do what it does in the night hours, consolidating, clearing, restoring, processing the day's experience into something integrated and stored. This is not wasted time. It is some of the most productive time the brain has. It just does not feel like productivity because you are not present for it in the usual way. You do not need to be present for it. That is the point. That is the gift. The brain during sleep moves through cycles, and within those cycles, through stages that are as distinct from each other as waking is from sleep. In the deeper stages, the slow wave stages, the brain produces large synchronized electrical waves visible on monitoring equipment as rolling hills of activity. Neurons that fire independently and rapidly during waking begin to synchronize, large populations of them rising and falling together in slow rhythms. The body's restorative chemistry is most active here. Growth hormone is released. The glymphatic system, a network of channels that clears metabolic waste from brain tissue, becomes most active during deep sleep, flushing out the byproducts of a day of neural activity. The brain is cleaning itself while you are not watching. In the lighter stages and in REM sleep, a different quality of processing occurs. More active, more associative, the stage where most dreaming happens. Memory consolidation shifts from short-term to long-term storage. Emotional experiences from the day are processed and integrated, stripped of some of their immediate charge, while their meaning is preserved. You wake. If sleep has done its work, with the same memories, but a slightly different relationship to them. The sharp edges softened, the emotional weight redistributed. Not because anything changed in the world, but because the sleeping brain finished processing what the waking brain began. This happens every night. It has happened every night of your life. Without instruction, without effort, the brain moves through its cycles and returns you to morning changed in small ways that accumulate into everything you are. The light of the stars is still arriving, even now, past the clouds, if there are clouds, past the ceiling, through the air of the room, attenuated to almost nothing. by the time it reaches you here, but arriving. Photons that left their sources years, or decades, or centuries ago, that crossed interstellar space in a straight line and entered the atmosphere and bent through the troposphere and scattered and refracted and finally dispersed into everything around you. Some of them are reaching your skin right now. Not enough to feel. Not enough to measure without instruments. But the physics does not stop at the roof. Starlight fills the night in all directions. It comes through walls in quantities too small to register. It has always done this. You have been bathed in starlight every night of your life without knowing it. The atmosphere bent most of it, scattered it, absorbed some wavelengths and transmitted others, but some always gets through. Some always arrives. The universe does not stop sending its light because there are walls and ceilings in the way. This is a small fact. It does not change anything. But there is something settling about it, about the continuity it implies. The same light that ancient people watched tremble in the clear sky above them is arriving here. Now, in this room, in this moment. The walls are thinner than the distance the light has traveled. Your breath is the most immediate atmosphere you have. The air moving in and out of your lungs is a small version of the same process happening across the planet. Gases exchanging between living things and the larger body of air surrounding them. Every exhale carries carbon dioxide outward. Every inhale returns oxygen and nitrogen and trace gases inward. Your body is in continuous exchange with the atmosphere, never fully separate from it, always participating in the slow cycling of elements through air and water and living tissue. The carbon in your body has been in that cycle for a very long time. Some of it was once in the atmosphere as carbon dioxide, absorbed by a plant, built into its structure, eaten by something, passed through generations of living things, released and reabsorbed, cycling. The specific atoms in your chest right now have histories that stretch back through biological time. And the oxygen entering you with each breath was released by plants and by phytoplankton in the ocean. The same organisms that have been oxygenating this atmosphere for over 2 billion years. You are breathing what they made. You have always been breathing what they made. The breath feels private and internal. It is also enormously shared. Let it be slow now. Let the exhale be a little longer than the inhale. Not forced, not controlled, just allowed to find its own length. The body knows this rhythm. It has known it since the beginning. Somewhere between one thought and the next, sleep arrives, not announced, not scheduled. It comes the way the tide comes, the way you can watch the water and watch the water and watch the water, and then suddenly realize it has moved without you seeing it move. The last thought you remember will probably not feel like a last thought. It will feel like an ordinary thought, slightly softer at the edges. perhaps beginning to move in a direction that waking logic would not follow. And then there will be a gap. And on the other side of the gap, morning. Everything between is the brain's own private work. You do not need to help. You do not need to prepare. You do not need to make sure everything is in order before you go. The order is kept without you. The stars continue their patient shining. The atmosphere continues its restless bending of the light. The earth turns as it has been turning for 4.5 billion years, carrying you through the dark and toward the morning, steady and reliable, and completely indifferent to whether you were worried about it. It does not need your worry. It never has. The only thing left now is the breath. In and out. The weight of the body held. The quiet of the room. The stars are there, past everything, steady in the ways that matter. The light is still coming. Sleep well. Take whatever time the night offers you. And when morning comes, it will come gently, the way light always comes, slowly at first, then all at once, bending through the same air that made the stars tremble, arriving at eyes that rested and finding you here, still here, quietly continuous with everything you were when you lay down. Good night.